All right, welcome back to the second part of Notes 9.2, where we are looking at arithmetic series. All right, so remember, series is just a fancy math word for finding the sum. Okay, now with arithmetic series, okay, with arithmetic sums, because you're adding or subtracting, like the pattern is adding or subtracting the same number every single time, the numbers are going to be getting, bigger forever, or I guess more negative forever. And so when you add them all up, like if you're trying to add an infinite amount, you're going to get infinity or negative infinity. So the type of series that we're going to be adding up, or the type of sequences that we're going to be adding up, have to be finite. Okay, they have to have a specific amount of terms, or I'm only asking you to add up a specific amount of terms. And when you do that, you're going to need formulas. It'll make it a lot easier. And let me show you why you're going to need formulas. All right, look at a problem like number 5. Find the sum of the integers from 1 to 100. So that means I'm asking you to find the sum of every single whole number from 1 to 100. And I don't know about you, but I certainly don't want to sit on my calculator and do 1 plus 2 plus 3 plus 4 all the way to 100. Okay, so there are 2 different formulas that we can use depending on what we know. Depending on what we know, or in other words, what we're given. Okay, so I do need to go over real quick what everything stands for. All right, so N, all right, you see the N, it's here and here, okay? N is just the number of terms, right, you are adding up, okay? So if I want to find the sum of the first 10 terms in a sequence, then N would be 10, okay? A1 is still the first term. All right, A sub N is the nth term, all right, sometimes referred to as the last term, okay? And so that's everything in this formula. If we go over here, that also has an N, that has an A sub 1. S is just a way to say that I'm finding a sum. That one has an N. Okay, so the only other variable is D, which we know from the other side is the common difference. Again, that's the number you're adding or subtracting every single time. Now, because we're actually finding a sum and not just an equation or a formula, all right, keep in mind that this time you do replace N with a number. Okay, you do replace N with a number. Sorry, I got a little sloppy there. All right, and then one other thing, let's see, I want to talk about is this particular formula right here, this first one, looks a little bit different when you get to ALEKS. Like if you read any of their explanations, they write the formula like this. They do N times the A1 plus the A sub N, and then they put the whole thing over 2. They mean exactly the same thing. All right, whichever way you prefer to type it in your calculator, that is certainly completely up to you. All right, so number 5 here says, let's read it again. Find the sum of the integers from 1 to 100. All right, so let's think about what we know. How many numbers are there? Because that's what N is the number of terms you're adding. How many numbers are there from 1 to 100? That's 100, okay? So that means we're adding up 100 terms. Do we know the first one? Yes, we do. Do we know the 100th one? Again, that's kind of like the same thing as saying, do we know the last one? Yes, we do. Okay? And so and technically we can list the integers out. All right, so we definitely can also find the D value if we needed it. All right, but think about what I know. I know how many terms, which I need to know for either formula, doesn't matter. I know A1, which I need for both formulas. But I also know the last term. I know the nth term. Okay, I know the nth term. And so because I know the nth term, this first formula is going to be ideal. Okay, so and really this is the only time you can use it. So this is ideal if you have first and last term. Okay, if you don't actually know the last term, then you're going to have to use the second formula, which we'll see. Yeah, I have an example of that in a few minutes. Okay, so all I have to do is just say that I'm finding the sum of the first 100 terms, and then I'm literally going to plug 100 in for n. Whoops, that's supposed to be a 2. I'm going to plug 100 in for the n, and then I'm going to plug in 1 for the a1 and 100 for the a sub n, and then I'm going to pull out my calculator and do some work. All right, so I know that 100 divided by 2 is 50, 1 plus 100 is 101, and when I put it all together, I get 5,050. Okay, that type of question actually comes up on the SAT, so maybe in the non-calculator section, so maybe that'll help you. Okay. All right, number 6, find the sum of all odd integers from 1 to 100. So let's think about what my sequence would look like. All right, odd numbers start at 1, but then they go 3, 5, 7, okay? And since I'm stopping, like I'm going all the way to 100, but I want the odd, I would actually stop at 99. Now, because I'm only doing the odds and not all of the integers, I got to think, well, how many do I have? Well, if I do them all, I have 100. If I do the odd ones, then I only have half that many. Okay, I only have 50. We definitely know the first one. And do we know the 50th odd number? The 50th odd number is what this means, which is the last odd number. And we actually do know that. And so again, we can use the shortened formula, but n is 50 now, and a sub n is 99. All right, so I can do 50 divided by 2, 1 plus 99, and then multiply those two values. Okay, now I do want you to notice something. All right, just because I had half as many numbers, notice I did not get exactly half of the sum from number 5. All right, and there actually is a reason for that. Okay, if you think about all the even numbers, okay, if you think about all the even numbers, all the way up to 100, every single even number is 1 bigger than the odd. 1 bigger, okay? And so that means that if I were to add up all the even ones, and since there are 50 of them, my sum will be 50 more than the odds, okay? And you could actually work out the evens, and you will see that you should get 2550. Just something if you want to go back and try it. All right, next problem. Find the sum of the first 30 terms of the following sequence. So I told you I want the sum of the first 30. So n must be 30. And then I give you the sequence, which I can certainly pick out a sub 1. All right, but this time I don't tell you what the 30th term is. And I'm not going to sit there and figure it out either, okay? But what I can figure out pretty easily is what is D? What is D? What am I adding or subtracting every single time? And that is 3. Okay, so based on what I have, the second formula, the one that was a little bit longer, all right, is going to be the more ideal formula. All right, and here it is, just so I don't have to keep scrolling up and down. And if you want to move the D in front of the n minus 1, you certainly can. All right, the only reason I wrote it the way I did on the paper is because that's how it is on the SOL formula sheet. All right, and look, I have an N, I have an A sub 1, and I have a D. So I have everything I would need for this particular formula. So N is 30. Now I will tell you, if you're going to use most calculators or Desmos do not allow you to type in brackets. So you're just going to have to use a parenthesis there. All right, and then we have 2 times A1 plus D times N, which is 30, minus 1. And you can type it in exactly like that in Desmos, or you can choose to do the individual pieces. Make sure you follow the order of operations. I will tell you, again, we're finding S30. You can do the work yourself. You will get 1,335. Okay? All right. Now, I need to pause it for just a second. All right, sorry about that. I know it didn't seem like I was gone for long, obviously in the video, but I just needed to pause it for a quick second. Okay, now, last one is going to be a little different than any of the ones we've done before. You might even want to put a star beside it. All right, it says compute the sum of 15 plus 10 plus 5 plus ... all the way down to negative 200. All right, so let's think about what we know, all right, and what we don't know, what we usually have to find. All right, do we know n? Meaning, do we know how many terms we are adding? Unfortunately not. Okay, so let's hold off on that. But we do know A1. We can definitely find what D is if we need it. And we happen to know what the last term is, even though we don't know which term it is. Okay? So we have to figure out, because both formulas require us to know what n is. Both formulas require us to know what n is. All right, well, we're actually going to kind of work backwards. We're going to kind of work backwards to figure it out. Okay, so I'm going to do some side work. And I'm actually going to go back to what we did on the first part of the notes, where we wrote an equation, or we found a formula. Okay, so you remember us doing that? We said A sub n is equal to A1 plus D, which is negative 5 in this case, times n minus 1. Okay? And then we spent some time simplifying it by distributing the negative 5 and adding like terms. Okay? So now we have a formula. Well, think about what we are trying to find. We're trying to find an n value, and we already know what A sub n is. We already know what the last term is. We want to know which term is it, okay? Is it the 20th term? Is it the 75th term? Like, which term is it? But we already know the answer to it. So I can substitute that in and actually create an algebraic equation that I can solve, okay? So I just need to figure out how I need to solve for n. So I'm going to subtract 20. And then I'm going to divide by the negative 5. And that tells me that n is 44, which means negative 200 is the 44th term. And I'm adding up 44 terms. And so then I just need to decide which formula to use for the sum. Well, since I know the first one and the last one, I'm going to use the shorter of the two formulas. All right, so I'm going to do n divided by 2 times a1 plus a sub n. And plus a negative, sorry I got sloppy on you, is a minus. All right, and then you can type all that in the calculator at one time, or you can do the two pieces separately and then multiply them. You should definitely practice on your own if you're watching this for the first time, and hopefully you get negative 4070. Okay, and that's all I have for arithmetic sequences and series. And so the homework that goes with this is in Alex again. It is called homework 9.2. And as always, you will be submitting photos of your work. And for the few at the beginning where you're just deciding if it's arithmetic or not and finding D, you still need to write down the answer to those problems on your paper. The rest of them, I should definitely see some work. Okay, so again, you want to have every problem written down on your paper, even the ones that don't require work. At least write down the answer. Okay, and I hope that you felt like arithmetic was pretty easy. It's just some formulas, and you don't have to memorize the formulas. Okay, you just need to know where to get them from your notes. And I'll see you next time.